What's going on, guys? In today's video we'll be starting a new topic which will be parametric and Cartesian equations. Before looking into any of the examples, let's look at the little note that I've written over here. It says if the coordinates of the variable point p of x, y, z equals to x equals to f of ti plus y, y equals to g of t j, and z equals to h of tk, then the vector equation becomes r of t equals to f of ti plus g of tj plus h of tk, where t is a parameter and the variable points over here are parametric equations. A simple, straightforward note to ourselves before we look into any of the questions. So yeah, let's start with the first example now. So looking at this first example, it says the position vector of a body is given by r of lambda, which equals to 1 minus lambda I plus lambda squared j, where lambda is greater than or equal to 0. It says A, find Cartesian equation and state the domain, and B, sketch the path of the body. So we'll start with A over here. Find the Cartesian equation. First thing, like we'd figured out in the parametric equations, was rewrite x and y in terms as their parametric equation. So x then becomes 1 minus lambda in this case, and y equals to lambda squared. So Cartesian equation, we're trying to find y equals to y in terms of x for Cartesian equation. Next step, it says lambda is greater than or equal to 0. Let's find values of x that define within this. So x equals to 1 minus lambda, rewrite this, lambda equals to 1 minus x, and let's find the domain to which this is possible. So if lambda is greater than or equal to 0, let's rewrite this. 1 minus x is greater than or equal to 0. Rewrite this. X is less than or equal to 1 in this case, because we swapped the signs over with the minuses. Now that we've done that, we can rewrite this into that. So y then equals to 1 minus x all squared, and it's defined for x less than or equal to 1. So that is A, Cartesian and stating the domain. Now let's go on to B over here. Looking at B now, we developed the Cartesian equation, which was y equals to 1 minus x all squared for x less than or equal to 1. Sketch the path of the graph, coming back to E11. We have y, we have x. 1 minus x, so this will be at would be at 1, 0, 0 in this case, and x is less than or equal to 1, so it won't be an open circle, it will be a closed circle over here. This path will be something like that. If we want to further find the x and the y-intercept, we let x equals 0, y equals to 1. So y-intercept is y equals to 1. And yeah, so to sum it up, what we did, first we changed this vector equation into its parametric equation, separated the x and the y's. Then we rearranged to find the x values that were defined within the domain, and then subbed it into the second parametric equation, which was y equals lambda squared, which then led us to this with the the described values for x in this case. So that is how you do example 1. Now we're going to example number 2.